Hey Momo, this is Mr. Brennan. I was just thinking about on the way home, I was just thinking about the problem you were talking to me about. I think I've got it here. R1 and R2 in a branch that we'll call branch A, R3 and some unknown R in a branch that we'll call B. I'm just gonna call this a 10 volt battery that's going to deliver some current to this point right here, and the current will split whatever I is. It splits into IA and IB. The current that flows through R1 is IA. That same current must flow through R2. We can make the same argument about IB. Whatever IB is, if it flows through R3, it must also flow through RX. I've got this dotted line here because I'm just trying to show like that's the magic bar that they had put in to that they had put into the circuit, and if that was a real like connection, then the voltage from this point down to here must be the same for both. But I think what they're implying is that what if you put a light bulb in here or another resistor or any kind of an element other than just a wire? How could you ensure that no current would flow in this particular element, whatever it might be? So the way to make that happen is we don't have to assume that IA and IB are the same, but we do have to meet the requirement that V1, the voltage across this resistor here, has to equal V3. If it does, then the voltage at the red dot must be the same as the voltage at the blue dot. What that would mean, of course, is that there would be no voltage difference between these 2 points. And if you did put a light bulb in there or a resistor, then the fact that there's no voltage difference between on either end of the ends of that element would mean that there's no way for current to flow through that element. Okay, so it's not a bar, it's not a short circuit, it's just a placeholder. It's kind of a visual element. They're saying, hey, what if you put something there? How could you ensure that no current would flow through it? So to make that happen, in order for us to make V1 equal V3, so for example, if there's 10 volts and the voltage from this junction down to the red dot is 7 volts, then the balance of that voltage, the other 3 volts, would be from the red dot down to ground. And if we can make that happen for both the red and the blue dots, we would get no current flow. Okay, how do we make that happen? Well, the ratio of the resistors in each branch must be the same. That is to say that the since IA times R1 is 1 voltage, IA times R2 is another voltage, and that all has to add up to 10 volts. I think you can pretty quickly convince yourself that the ratio of the resistors must be the same in each branch. So R1 over R2 has to equal R3 over Rx. A little bit of algebra here, getting Rx into the numerator and multiplying through by R2, dividing by R1. You get R3 times R2 divided by R1. I don't know if I've labeled it the same way as your problem, but if you made that happen, if you made this happen here, then the voltage at the red dot to ground and the voltage at the blue dot to ground would be the same, and no element that you put in here would have current flowing through it. So still a little bit of a contrived problem, but I think I eventually sort of figured out what they were talking about here, and I hope that is helpful for you. Okay, take care. Bye.